Howdy y'all. My name's Mitchell Kuppersmith. I'm a design engineer on the product team, and over the last couple months, I've been using a lot more AI coding tools. As a prototyper, I find them incredibly useful for just quickly testing out ideas or working across the stack in fields I'm less familiar with. I always have to hop between working on front end or back end or even sometimes in Figma to test out different designs. I've been using Cursor for the last couple months, as well as other CLI agents like Claude Code, Codex, or even OpenClaw. One pain point that I find with these tools is that there's a real opportunity cost incurred from stepping away from my computer. Sometimes I start a task on one of these tools, but the agent just gets stuck on it, and I can't continue until I get back, or I also sometimes just run out of space on my monitor setup, and sometimes I just want to get away from my computer entirely, but still get my work done. Because of all of this, I started trying to think, how could I solve these problems by bringing my agents from the digital world into the real world? Agent Center is my solution for these problems. It's a spectacles lens for connecting to your various CLI agents for quick controls and glanceability. Spec supports 3D spatial positioning, which allows me to create multiple AI chat threads all over my desk to quickly check what my various agents are up to at any given time, as well as interrupt them to give them guidance or permissions to do various actions on my computer, no matter where I am. The project consists of 3 different components. The first is the bridge daemon. This is a background process which manages communications between the command line interface agents and the actual Supabase backend. The bridge daemon passes both input to the agents and output back to the client. This also hosts 2 MCP servers, one for sending screenshots to specs, and another for managing permissions of the actual agents. The second component is a SnapCloud server. This acts as the communication layer. It sends information from my bridge to my specs and vice versa. Then we have the Spectacles client, and this is the fun part. This acts as my control center for my various agents, and it's where we have all the fun interactions. So let's get started. We have a couple different requirements for this, but the first thing that you should do is install Lens Studio 5.15.4. This is the latest Lens Studio that works with Spectacles, so it's what we suggest you download. Additionally, you want Node.js 18 Plus installed. Any of the Node.js versions newer than that work as well too. You'll also want to allow for extended permissions on your Spectacles, and you can do that through the mobile app. This is because this project has BLE keyboard support, as well as user camera and user microphone input. That's sensitive data, and we want to make sure that it's only being sent whenever the user is giving consent for that. Additionally, you're going to need some coding agent CLI installed on your computer. Claude Code or Codex work really well for this. Now jumping into Lens Studio, the first thing that we're going to do is create a Supabase project. In order to do that, go to Window, Supabase, and that will open up this panel right here. On this panel, you can press Create a New Project. From here, we can give it some creative name, so we can call this Agent Center Backend. And we want to come up with some good database password just to keep user data secure. So, like all good passwords, this one will be randomly generated by me smashing my keyboard. Data is secure. Next, we want to select the region, which will be East US, North Virginia. And we're going to enable data API and security. Now you're going to see right here, if we click on this, this will have some additional data about your project. This is where you can find your API keys. And what we're going to do is on the project itself, you'll be able to import the Supabase credentials to the project via the automated Supabase panel. Now for step 3, what we're going to do is we're going to set up the CLI daemon. So in order to do that, what we're going to do is we're going to CD over to Supabase in the terminal, and I have a script here called setup.sh, and this will do a lot of the hard work for you. In order to start running the script, you're going to want to go over to your Supabase project. You're going to copy paste your project ref within the terminal, and this will begin running a script which will upload a couple edge functions, a real-time channel broadcast policy, as well as some database schemas to make sure that we have everything we need for communicating between the computer and the Spectacles client. So this will push over this remote database migration, and this will have all of the database stuff that we need. We can generate some new secrets. Now what we'll do is we will input the Supabase anon key, which you can get from the dashboard of Supabase. So you just want to copy paste that in there. And that should set up everything you need on the server side. So now if you look at your Supabase project, and let me pull that up right here, you'll see if you go to the edge function section, here's all the functions that you need. You'll also additionally see in the database section that we have our database schema set up. So you can see the tables of kind of the bridge agents, you can see how the auth is hooked up into that, and then you can also see the Cursor API key and Cursor agents. The next thing that we're going to want to do is actually pair our coding agents to our lens. So in order to do that, we're going to turn on our spectacles, hop into the lens, and in Lens Studio, press Preview Lens, go over to the terminal, make your way over to the bridge, so CD bridge, and then you're going to run npm install, and this will install all of the requirements that you need, and then you're going to want to run npm link. And this will make it to where, no matter where you are, you can always run specs, agent, bridge, and that will pop up this little terminal UI right here. So after pushing the lens to device, you're going to see this view right here that says no agents connected. And the way to change that is we're going to navigate over to the settings panel. And from the settings, we're going to press connect on local agent. This will show you this screen right here where it asks for a user API key. And we can generate this by going over to the terminal UI, pressing add new agent, go over to whatever coding agent you want to use, give it a little nickname. And this will create a 6-digit code. And we're going to enter that 6-digit code we just generated. And then we're going to press pair, or on your Lens Studio, go over to the settings tab, make sure that your device type override is set to spectacles and your simulation is set to no simulation such that you can use keyboard whenever you're previewing your lens. Press connect, click on the enter 6-digit code, paste it, enter, and then just press pair. And this should pair your coding agent with its nickname to your specs. So now, anytime that you want to access your specs, you can just go back to this terminal UI. Let's first give it permission to do screen sharing so it can send screenshots from my computer. And we just press activate all agents, and now we can access our Claude code directly from specs. So now, if I want to send a message to Claude code, I can always click on Claude code. I can just say, hello world. We can send that message right over. And what's cool is this is connecting to the Claude code that you already have on your computer. And if you want, you can actually restart the conversation on your computer again by just pressing open in CLI. And this will directly open up the conversation that you were having on specs onto your computer. So if you want to go back and forth between the two modalities, that's an option that you can do. And now we can start using our coding agents on specs. So no matter where you go, as long as you're running specs agent bridge, you can press activate and your agents are always accessible from your specs. For some additional features you can add on top of the lens, something else you can do is you can go to Window, Remote Service Gateway Token, and then you can generate tokens. And these will allow you to access AI services within the lens. And we're going to put these in here. And the reason we want to put Remote Service Gateway credentials in here is this allows us to power up the smart features that we have in the lens, and we'll talk about those a bit more later. For a bit of a technical deep dive in regards to how this project works, the key pattern to understand here is the communication between the lens client, Supabase, and the daemon running on your computer. As an example for how this works, let's say we wanted to access this Hello World chat right here. Whenever I'm on the Spectacles client and I click on that topic, this will send a request over the Supabase real-time channel over to the bridge daemon. The bridge daemon will then receive that request and serve up the information associated with that topic ID. The reason we store the entire chat conversation and all of this data on the computer itself is to maintain data privacy. Data governance of what the user is talking to their agents about is fully stored on their computer, and we want to make it to where data is only served up to the client as requested by the user. No erroneous data should be sent over to the client without absolute necessity, and we want to maintain minimal data within the cloud as much as possible. The only data that's stored on the lens itself is the read status of whether or not a conversation is read, the theme choices, so if you want to make your little guy look less like a robot, more like a cat, you always have like the option to do that. So these are purely aesthetic choices that you can do. And then we also have a couple smart features, and smart features indicate things like smart summaries, prompt suggestions, topic renaming. We also store things like last open conversation to have continuity such that you can go back to the conversation you were just reading. Repository selection, so if you want to link to any specific repositories for working, we store IDs of those. Pending deletions, so if you're trying to delete a conversation that you're having with your agent, but that conversation failed to delete, we store it until it deletes, as well as the actual paired agents. As an example of overall data flow from script to script, component to component, whenever we want to send a message from the lens, we first give input to the agent input bar via the Automated Speech Recognition API, also known as ASR, or there's also the option for a Bluetooth Low Energy, BLE, keyboard. This will then get shown and stored locally before also sending that same message over the bridge agent provider. The bridge agent provider will then format the message payload and use SUPA-based service to broadcast the message over the real-time channel. Meanwhile, the bridge is always listening to the real-time channel when it's activated for these broadcasts, and will pick up this user message event. This will first look to see if this matches an existing conversation, and if not, will create a new one on the bridge. Next, it will handle the message by saving the content for future reference, and call the specific driver responsible for that CLI agent with that input. We then await an output from the CLI process, and send that back over to the users for them to see on specs. Because this is connecting to CLI agents you already have running on your computer, we connect to all the same MCP servers and skills that you already have. That being said, we also do add 2 additional servers. The first is the aforementioned MCP artifact server. This server exposes tool calls to your agent that give it the ability to take screenshots and render text from files. So if you want to look at your Git diffs, or if you want to see what's going on in Lens Studio when you're away from your computer, you're able to ask your agent that and you can see it on specs. Additionally, the second server that we have is the MCP permission server, and this server acts as an intermediary between AI agents and tool execution on your computer. This does have different behaviors for different CLI agents, so do be mindful of that. For Claude Code, this uses the permission prompt tool CLI flag, which intercepts Claude Code permission queries and will gate whether or not an action occurs. Most communication between the components in this project follow the similar pattern of relaying between computer and Lens via SUPA-base, with the exception of Cloud Agent APIs, and that's because those don't run on the user's local device. So for those, I have SnapCloud directly call those Cloud Agents, and we have an example of that in the repository if you'd like to take a look. However, if you want to add another local CLI agent, take a look at the driver examples that we have within the bridge folder. On the Lens side, we also have integrations with Remote Service Gateway for additional smart features on top of your coding agents. From the message data, we can use RSG in the Lens for things like smart summarization of notifications, prompt suggestions, renaming of topics, and even explanations of permission requests so you know what your agents are actually asking to do. These are all things that require very simple reasoning but benefit from generating as fast as possible, so we use Gemini Flashlight to keep latency and cost low. I turned these permissions off by default such that users have to opt in for additional data processing because this is sensitive data. If you want to add new services, they exist within the services folder and are wired to the user via the chat settings panel. The project allows for you to create 2 different kinds of settings. You have the chat settings panels, which are per agent settings, and this is for things like smart features, what model to use, what folders and repositories it has access to, as well as unpairing and deletion of data for that specific agent. We also have app level settings at the settings list view, and this is where we have things like new pairing flow, personalization for voice note behavior, Bluetooth keyboard pairing, which is what's driving the requirement for extended permissions plus experimental, as well as an overall data deletion option if you want to delete all of your data. When it comes to the scene of the Lens, something you'll notice in this project is that the scene is rather sparse. I only have like 3 objects in here. We have Spectacles Interaction Kit, the Agent Manager controller, and the Remote Service Gateway credentials. If I inspect the preview, you'll notice that's because almost everything gets instantiated at runtime, and we can see that if we collapse here, you'll see all of the stuff in the Agent Manager controller. And what we do is we generally split things between input, gesture, and user interface. The input is primarily controlled through the agent input bar, which handles things like the Bluetooth keyboard, ASR, camera gesture input, and then we also have additional gestures such as the voice note gesture and a hand-docked menu for summon and unsummon behaviors. The actual chat and stateful UI largely goes through the Agent Manager panel and is handled by other scripts like Agent Object for the specific robot. I mostly create UIs programmatically rather than through prefab or actual scene editing, since this allows me to more easily do things like responsive layouts, component reuse, consistent styles of actually created components, and from a more functional perspective, it also allows me to avoid corruption of component linkage, as well as pass these scripts over to AI for more easy synthesis of novel views. There's a couple of exceptions to this, like whenever an element requires more visual tuning or I want to isolate it for more iteration. Like whenever I created the mesh and controller for the robot visual, I did so as a prefab since that required a lot of micro-tuning to get it to where I wanted it to be. But even then, I instantiate it via script rather than placing it in the scene through an input. If you want some additional examples of how to do stuff like this, look to the FastUI asset in Asset Library. Programmatic UIs rely heavily on a few scripts. The first is Dirty Component, and this is a base class that we extend for telling a component when to recalculate layout. This is used for things like chat panel, wrapping text input field, and chat selector, which are constantly changing size or layout. We also have UI builders, which is another script I use for creating common components that require consistent styles, which are then defined in the UI constants file for things like sizes or things like commonly repeated textures, as well as UI animations, which are some common animation patterns that we use for having similar motion across different parts of the lens. Programmatic creation is a pretty large part of this project in general. Almost all the sound effects, shaders, and meshes are made through generative coding. Coding agents are really good at writing scripts or interactive programs for making the assets that you need. For example, for actually creating the robot mesh, what I did is I had a coding agent write a script for an open source 3D modeling software, which then created the mesh that I needed as well as the UV maps for it. I then brought it into Lens Studio and had another agent write Lens Studio shaders for me to create this animated SDF face that I have on top of it. Sound effects are made in a similar way, where I have a coding agent create dashboards for me to edit the sound effects to exactly what I want them to sound like. Using these tools in your development pipeline can help you cover areas that you have less expertise with, while still having the level of customization that you want to get. If you want to extend this project or merge it into your own workflows, I'd heavily encourage that. There's a lot of room for customizing this project. Maybe you want to add Git visualization to show you where your agents are working within the Git tree. You could add tools for 3D visualization of your data or artifacts, spatial anchors to make sure that your agents are always at your desk whenever you come back home. If you end up using this project as a base or extend it any further, please post it in the r/spectacle subreddit. I'm really excited to share this with y'all, and I can't wait to see what y'all do with it.